Welcome to 4.3 Exponential Functions in Common Core Algebra 2. I think after 4.2 this will be a nice breath of fresh air for you because this is not that hard. And we've basically talked a lot about exponential functions in Algebra 1, so there's not a lot new here. But we thought it would be important to make sure that we review it quickly before we move on to more extensive exponential functions. So, if you take a look, if you want to read here, exponential functions, those whose exponents are variables, are extremely important in mathematics, science, and in engineering. Yes, that is very true. So basic exponential functions, this is something that should be on an index card or in your app. Y equals b to the x, where b is greater than 0 and b cannot equal 1. Okay, so think about what that is. So you're going to have two situations here. One situation is going to be when b falls between 1 and 0. And the other one is going to be when b is greater than 1. So we're going to look at two different situations here. So the first one we're going to look at is the second one, the b is greater than 1. So in this case, our base is 2. Our exponent is x, and this is y equals 2 raised to the x power. So why don't you take a minute without using your calculator, because I don't think you need it for this, and fill out this table. So 2 to the negative 3 is equal to 1 over 8. Now you can do the decimal equivalent as well. All right, so 2 to the negative 2 is 1 over 4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. Anything to the 0 power is always 1. 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. So then it says sketch the graph. So we filled in the table. We did not use the graphing calculator. And we want to sketch the graph on the grid provided. I always go back and read the question just to make sure that I'm answering I'm doing what I'm supposed to be doing. So let's do the easy ones first. 4 is here, 8 is here. And then what happens is, if you remember this from Algebra 1, it gets very, very close to our x-axis, but it never touches it. So this is the equation y equals 2 raised to the x power. That x-axis is called an asymptote. Love that word. Asymptote. And what that is kind of an invisible line that a function will get closer and closer to, but not actually touch. All right, so now let's take a look at the next one. Again, if you need to pause, you know how to do this. Pause it, write down what you need to, and come back to me. Exercise 2. Now let's consider when we have a number between 0 and 1. So fill out the table below. So we're going to fill out the table below, and we're going to sketch the graph on the axis provided. Again, I need to use the mission literacy as well because I tend to go right to the math and not really pay attention to what the question is asking me. All right, and if you're a math people like I am, that's something we need to work on. So this is going to be 1/2 to the negative 3 power, which is positive 8. This is going to be 1/2 to the negative 2 power, which is positive 4. This is 1/2 to the negative 1 power, which is positive 2. And again, anything to the 0 power, we all know is 1. Then we have 1/2 to the first, which is 1/2, or 0.5 if you want to do the decimal equivalent. 1/2 to the second power is 1/4. And you can see that the pattern here kind of follows what we just did, but kind of opposite. So we start at negative 3 at 8, all the way up here. Then we go to 4, and then we go to 2, and we go to 1. And now it starts getting smaller and smaller. Again, please, when you draw these, never ever touch that x-axis. So this is the equation y equals 1/2 to the x. Pause, write down what you need to, and we're going to draw some conclusions on the next page. So as you can see on this one, I drew both of them in here. So you have them on your page. but I needed to put them so I wouldn't have to flip-flop between them. So I put them both on one graph, and you can see the red one is my y equals 2 to the x, and my blue one is y equals 1/2 to the x. So based on the graphs and the behavior you saw in exercises 1 and 2, state the domain and range. Again, see here, I'm going back to reading. State the domain and range for not only one of these exponential functions, basically for all exponential functions in this form. All right? So your domain, your input set, which are also your x values. X values means, do we have a bound on the left or on the right for either one of these? Hopefully you're saying, no, we don't. They go on forever. So there's a couple of different ways that we can write that. We can either say negative infinity is less than or equal to x, which is, we shouldn't say less than or equal to, because you actually can't hit infinity. Infinity less than x, less than positive infinity. Or another way we can write this is simply with a capital R. It's called a bold R, and what this means is all real numbers. And that's the way we write it in upper mathematics. Our range, in this case, if you think about our y values, our lower bound is the x-axis. So our lower bound is 0. So we have 0 less than y, because remember, it doesn't actually hit 0, which is less than positive infinity. Or if you wanted to write this in integral notation, you could write it as 0 and infinity, like that as well. And we could do the same thing with, over here, we could have done negative infinity, comma, positive infinity. So lots of different ways that we could have written this, because it doesn't say specifically how to write it. So we're just going to write it all different ways so we can make sure, oh, there's another way we can write this too. We can say y is greater than 0. That's the easiest way to do it. I think I got all the different ways. So now let's just take a look at these two examples and see if we can just come up with some generalization. Finish writing things down and pause it if you need to before I continue talking. So taking a look at this one up here, this is when our base, right? I said the base has to be between 0 and 1. So let's change that. So our base has to be between 0 and 1, not inclusive. Can't be 0, can't be 1. But it can be any fraction between 0 and 1. And it has to be positive in this case. All right? So when it's positive and we have an exponential function needs to be positive, because if it's not positive, it turns into something different. So we're not visiting that right now, but we will at one point. But in this case, when our base is a fraction, a positive fraction, less than 1, we know what happens to our blue. Take a look at the blue line, the blue curve, I'm sorry. The blue curve, it is a decreasing exponential function. And taking a look on the other side, here, when our base is greater than 1, not equal to 1 again, when it's greater than 1, this is going to be an increasing exponential function. Why do we exclude 1? If you had y equals 1 to the x, what would that be? Y equals 1 to the 0, y equals 1 to the 1, y equals 1 to the 2. Hopefully you realize that this would just be the horizontal line, y equals 1. So this is not an exponential function. So that's why we have to exclude when the base is 1. Copy down what you need to, and meet me at the next exercise. So there was a little cheat there. Sorry about that. All right, so exercise 4. Are exponential functions 1 to 1? How can you tell, and what does this tell you about their inverses? So please make sure, I've been trying to stress this mission literacy with you, that we always answer in complete sentences, and make sure you're answering all the questions that are addressed in one particular question. So the first thing I said is, yes, exponential functions are one-to-one, period. I can tell because it passes the horizontal line test. Therefore, the inverses of the exponential functions are also functions. So see how I address each one of those questions? All right, I'm not keen on that I can tell because. I don't know if that's a complete sentence. An English teacher might argue that with me, but I think I made my point. Write it down, and let's move on to exercise 5. Now don't read B before we get to 5, okay? So let's talk about A. Now consider the function y equals 7 times 3 raised to the x power. Determine the y-intercept of this function algebraically. And again, I always need to go back to thinking about what does that mean. What that means is it wants to know when x is 0, what is the y value? All right, so to do it algebraically, we simply y equals 7 times 3 to the 0 power, which is 7 times 1, which is 7. So I'm going to simply write the y-intercept, answer the question, is 7. Then it says, does the exponential function increase or decrease? Explain your choice. Now, the first thing I wrote down because I actually graphed this first in my head. The exponential function y equals 7 times 3 to the x increases because x increases as x increases, y increases. That shows a increasing function. But we also want to think about, because the base is greater than 1, just the things we were just talking about, because the base is greater than 1, it needs to be an increasing function. So it says create a rough sketch. Well, I know that my y-intercept is at 7. And I know the basic look of my graph is going to look something like that. It's an increasing function. So sketch means doesn't have to be exact. Just give an idea of what it would look like. When I looked at it in my head, that's what it looked like. Okay? Exercise number 6. Consider the function y equals 1/3 to the x plus 4. Well, how does this function's graph compare to that of y equals 1/3 to the x? What does adding 4 do to the function's graph? Now, if you had a graphing calculator at home, you could easily put both of these in there. But if you can't, you can make a table of values, and you can see what happens. And we can cheat a little bit because I can tell you that I can pretty much tell you that the y equals this one. Let's do this one in green. Y equals 1/3 to the x, crosses the y-axis at 1. And because the base is less than 1, we know it's a decreasing function. So we know it's going to look something like this. Y equals 1/3 to the x. Now, if you put this into your calculator, this one right here, 1/3 to the x plus 4, what happens is that our 1 for our y-intercept now changes to 5. 1, 2, 3, 4, 5. It changes to 5. This whole thing is going to shift up 4. So when we're all done with this, and be careful because our asymptote's going to change a little bit too. Because now instead of being 0, it's going to be here at 4. And I'm going to put that in so we make sure we do not go past it. So this one comes something like this and something like this. So this one is y equals 1/3 to the x plus 4. So what does adding 4 do to the function's graph? By adding 4, to y equals 1/3 to the x, it shifts, I like that word, shifts the function vertically, and you can even say vertically up because it's positive 4, because it's positive 4 units. Did we answer the whole question? We did. Determine the graph's y-intercept algebraically. And it says justify your answer. So we kind of already talked about that, but if they're asking us to do it algebraically, let's say we do y equals 1/3 to the x plus 4. And again, remember, x has to be 0. So y is equal to 1/3 to the 0 plus 4, which is 1 plus 4, which is equal to 5. So just make sure that you write down, because it's asking for the y-intercept. So you can say here that the y-intercept of y equals 1/3 to the x plus 4 is 5. Okay, so create a graph. We kind of did that already. So, and it says label the y-intercept, so we should do that. So this is 1, and this is 5. Make sure, again, I can't stress it enough to make sure that when you're done, you read everything and make sure you answer the questions. So, until next time, have a good day, and as always, make good choices.